All right, let's talk about some really big numbers. Like really, really big numbers. That's what we're going to look at today. But what the real topic here is something called scientific notation. But for now, let's just think of this as really big numbers. What kind of big numbers? Like the number of stars. Like if you were trying to count the number of stars, how many stars actually exist? And not just the ones that you can see in the sky, but how many stars actually are there in the whole entire universe? Probably a lot, right? Well, nobody really knows for sure exactly how many stars there are, but there's a lot. And the latest, greatest estimates by astronomers are that, wow, there's that many stars in the universe. That's a big number, okay? A 3 with a ton of zeros behind it. And that's not the only astronomically big number. There are other large numbers as well that we might deal with. Like if you wanted to get from our star to the nearest other star, how far away would you have to go? Well, you'd have to go this many kilometers. That's a long distance. That's a really big number. And if you were traveling that distance, the fastest you could go is the speed of light. And how far does light go? Well, let's say you let a particle of light go for a whole year at full speed. This is how far it would go. It would go really, really far. That's a light year in kilometers. Now, these numbers are just straight up crazy. Our human brains can't really comprehend how large these numbers are. And if you were going to start trying to do math with these numbers, addition, subtraction, multiplication, division, then it's going to start getting pretty tricky pretty fast. And we're going to, man, if you had to show all your work, all those zeros. Okay, so in order to take these crazy large numbers and make them a little bit easier to work with, what we do is we use what's called scientific notation. And it's a way to shorten long numbers, okay? And it's kind of like when we abbreviate things. Scientific notation is an abbreviation of a really long number into a shortened form, like writing MR period instead of Mr. So this is the number of stars in the universe written in scientific notation. It's a shorter, sweeter version of the same number. It's an abbreviated version of the same number. And to understand where we came up with that 3 times 10 to the 23rd power, we first have to understand how the powers of 10 work. So check this out. You know what 10 to the 0 is, because anything to the 0 is 1. And you know what 10 to the first power is, that's just 10. And you know what 10 squared is, 10 times 10 is 100. And if you multiply that by 10, you get 1,000. And then 10 to the 4th would be 1,000 times 10, which is 10,000. And then 10 to the 5th would be 100,000. And guess what? The powers of 10 have as many zeros as the exponent. So the number of zeros in each of these matches the exponent in each of these. This one has 5 zeros, 4 zeros, then 3 zeros, 2 zeros, 1 zero, and no zeros. Okay, that's crazy. So if I wanted to write 100 billion, all I have to do is count the zeros and write it out as 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11th power. Okay, isn't it a lot easier to write 10 to the 11th power than it is to write 100 billion? Yeah, so it's an abbreviation. We're going to use that to help us later. But first, what is 10 to the 7th power? Do you have to really use a calculator for this, or could you use the shortcut? Yes. And then, what's a shorter way to write 100 million? All right, once you think you've got those, let's talk about how to write really big numbers in scientific notation. All right, 10 billion is a really big number, but it's just 10 to the 10th power, because there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros there. 70 billion, well, isn't 70 billion just 10 billion times 7? Oh, so if 10 billion is 10 to the 10th, and 7 billion is 7 times that, couldn't we just write 70 billion as 7 times 10 to the 10th power? Okay, the standard way to write 70 billion is a 7 with 10 zeros behind it. Scientific notation is an abbreviation. It's a shorter version, but it still means the same thing. So how would you write, oh boy, look at that number. That's a really big number. How would you write that in scientific notation? Well, that's the standard way to write it. What we're going to do is notice that we could write this green number, and this would be that times 9.37. And then, since that green number with all the zeros and the 1 in front of it is 10 to the 12th, couldn't we just say that the blue number at the top in standard notation can be rewritten as 9.37 times 10 to the 12th power? Yeah. Okay, that's the same number written in scientific notation. Okay, the rule with scientific notation is instead of writing it as 937 or 93.7 or 0.937, you have to have one digit in front of the decimal. So we make it 9.37, and then we count the zeros for that green number. All right, here's an easier way to do it. If you had 60,000, 1, 2, 3, 4, so it's 10 to the 4th times 6. That's easy, okay? If you have 89,100,000, we are going to count the zeros, but notice that would be 891 times 10 to the 5th. But we don't want 891, we want 89.1. So we're going to put 8.91. We don't want 89.1. We don't want 891. We want 8.91. And since we went 1, 2, 3, 4, 5, 6, 7 places, we're going to say it's 8.91 times 10 to the 7th power. So actually writing things in scientific notation is really pretty easy. You just count how many spaces you have to move the decimal, and you put that number as the exponent on the 10. So the decimal goes there, and that is how we do it. Okay, 123 million. Where do we want the decimal? We want the decimal to be between the 1 and the 2, so it's 1.23. But it's going to be 1.23 times 10 to the what? 10 to the 1, 2, 3, 4, 5, 6, 7, 8. 1.23 times 10 to the 8th power is how you would write this number in scientific notation. And that was really easy, wasn't it? All right, you try it. Convert this really big number to scientific notation. Okay, what if you have a number in scientific notation and you want to unscientific notationalize it or something? What if you want to write it in standard notation? Well, could we move the decimal to make it 431? Yeah. And then we moved the decimal twice, right? But that 6 exponent says we still have 4 more spots to go. So 1, 2, 3, 4, 5, 6. What do we do with those blank spots? We put zeros in them, right? So 4.31 times 10 to the 6th power in standard notation is 4,310,000. Okay, notice the decimal moved 6 times because of the 6 exponent. So try that here. Write 2.2 times 10 to the 5th power in standard notation. See what you get. Okay, once you got that, we're all set, and we will try this some more tomorrow. See ya.